So this title is Algebra 1, Semester 2. It's the second uh, unit. The unit is two variable data. It's the third lesson, Shapes of Distributions Practice. It's on creatormath.com. It's under the Algebra tab. Here's the instructions. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. It is under the Algebra tab, and the notes will be for the appropriate pages that give background material to this. So this one says, what is the name of the distribution shown below? This is a classic distribution called a bell curve or normal distribution. Why is it called a bell curve? Because if you think of, sort of a bell shape, right? I can't draw it as well as it goes like this. That's exactly, remember a bell, just like a device that swings in there, right? That's the shape of a classic bell curve. A classic bell curve is weighted in the middle. You can see most of the data appearing under the middle, and then these things going off in this direction is called a tail, and this thing going off in this direction is called the tail. But this is a normal distribution. It is the most famous distribution. Be careful how I say this, but a lot of activities on Earth, especially when humans are involved, fall into the normal curve situation. All kinds of things start to fit this data when you start to track, whether it be traffic or all kinds of things start to fall into this normal shape, this normal distribution. It's the most famous distribution shape by far. That's why it's up first. What is the name of the distribution shown below? So now we take the normal and we start to skew the data. So notice it's not a perfect normal curve. All of a sudden a lot of data is starting to move over to the right on this one. So this one's called a skewed right distribution. It's a form of a normal distribution, but the data is skewing to the right. The data is all being lumped under here. And the idea of graphs for data is that our brain can picture the idea that most of the data is occurring over here rather than in the center. If there is a right skewed distribution, then it makes sense probably to you what is the name of the distribution shown below? Makes sense that there is a skewed left distribution. Here the data is appearing up closer in the beginning rather than at the end, rather than in the middle, right? So the normal distribution is the most famous. Skewed right and skewed left are classic sort of alterations of what's happening to normal data. What's the name of the distribution shown below? This one is a bimodal distribution. Bi means two, and you just end up with a series of data on one side split by a series of data on the other. This would show that the data is not all in the middle or being aggregated into one piece. It's literally there's a separation of data here, and we're seeing clearly from the picture that the data is not unified. There's something going on over here and a lot going on over here and nothing happening in between, right? Called a bimodal distribution. What's the name of the distribution shown below? This is called a plateau distribution. Also a classic. Doesn't show sort of an aggregation in the middle, but the sort of spread of a lot of the data across the presentation, across the picture of what's happening in the data, called a plateau distribution. Like the classic geography, there's a plateau, right, which is a high, flat region of land. So plateau distribution is flat like this on top. And we've taken the center out of the normal and split it over here and filled in the sides. What's the name of the distribution shown below? Comb distribution. All right, so it is largely fitting a normal understanding, but we're using sort of a combination of a bar graph situation, right, where the data is being represented by those bars, but notice the bars are starting to fill in what looks like a classic normal or bell curve distribution. What's the name of the following distribution? This one's interesting. There's different names for it, you guys, but this one's called dog food / Golden Gate distribution. Kind of, and you could probably make up your own names for it, but what's happening is the data is all appearing in these parts here. right? And there is no sort of center to this thing. The center's being hollowed out. It doesn't exist. So the data is all being pushed toward these areas, one side or the other, and it's extreme, having this sort of dip in the middle. I guess the reason it's called Golden Gate, is one of the reasons is it's like, remember the Golden Gate Bridge is a deck, two columns, and cables that run like this, right? And the cables hold up the decking, and that's your classic, lots of bridges are built like this. The Golden Gate's the most famous bridge built with this type of structural system. So notice I guess it looks like you've got these two things going on here. You would kind of have that in the middle. The other is the dog food. Looks like a dog bowl here, right? Dog food / Golden Gate Distribution. And there could be some other names that are slang and some more official names probably than this. Here's the opposite of that distribution, so to speak. What is the name of the following distribution? A truncated distribution. So what does the word truncate mean? It means to cut off. Notice the distribution, the normal curve. So everything starts with the normal, and then is sort of a modification of the normal. This is being cut off here and here. These parts of the normal are excluded, and everything is being forced into the center part of this area, right? So a truncated distribution. I don't know if I have a good example of this off the top of my head, but that's the way the data starts appearing, and everything, what's happening is it doesn't sort of slope down normally, it just sort of drops off. What's the name of the following distribution shown below? Linear distribution. So if it's a line, linear just means line. If it's a line, call it a linear distribution. That's what's happening. And a lot of times we'll have data in here, right? And we will be fitting a line to it. So it may not actually look like a line at first, but by the time we look at where does this data fall, we want to put a line right through the middle of it. And now the line is easier for our brain to process as to what's happening in this situation. What's the name of the distribution? Exponential. So also the idea of a distribution of data which starts slow and then just starts to explode up. And once it starts going up, it goes up to the stratosphere, right? And this is the classic, we're in the middle of a pandemic, right, when this is being recorded. This is the classic spread of a disease. One person gets sick and gets too sick, right? Each of those two gets too sick. Each of those two gets too sick. And all of a sudden you get to a point here where everybody gets sick all at the same time. And that's the idea of the spread of disease or the spread of a virus. And that's what's happening right now. We're seeing cases just go through the roof because there's nothing to slow it down. So that's called an exponential distribution. All right, a couple more. From our prior lesson, you should probably know that this is given the following box and whisker plot. Which distribution shape can we expect? So interestingly enough, now they're sort of giving us the idea that we know what a normal is. So here's the beginning of the data here. Here's the end of the data here. Here's the middle. This, in the box and whisker plot, which we know from the prior lesson, this is the mean or average. So the weight of all the data is in here. And it ends here. So almost try to imagine starting here and drawing sort of a hill up over this, and then going down and ending right here at the end. Notice it's not the normal curve, it's not the bell-shaped curve with the weight in the middle. Everything is skewed over to the right. So a skewed right distribution. I kind of like this. You're trying to look at a box and whisker plot and put it in terms of a distribution you might know in terms of these other names. Last one, what's the name of the data point which lies outside? So this is all of our data. Our data follows like this, they're all points, right? And all of them are aggregated here in the middle. This is a normal distribution. It's a bell curve or a bell-shaped curve of data. And then all of a sudden you have this point out here, right? This point is a famous point in statistics. It's called an outlier, right? Outlier. It's lying outside of the main group of data. This is an outlier. So it's a data point which lies outside of the data group. Most of the time when it comes to data, we'll take the outliers and we'll be like, that's an outlier. I'm not going to count that in the set. Look, it doesn't fit at all here. And that could be anything. Maybe a person got into the study that didn't belong or didn't fit the criteria, or maybe it was just a random event that happened that caused this outlier to happen, right? We're really looking for data to see what the bulk of the data is showing us. The bulk of the data is here. This item's out here. It's an outlier. Most of the time we'll ignore it. It's called an outlier. It's famous. It's one thing you got to know about. All right, you're finding this under creatormath.com. It's under algebra, and it is the second unit for the second semester.